All right. I think Microsoft the microphone should be okay now. Okay, so hello to everyone watching on the different platforms and anyone in the future who's joining in. My name is Maor. I'm from the Braavos team. Um, I gave a short introduction back in Sunday about our wallet. Um, so here at Braavos, we really utilize and leverage account abstraction on the Starknet network to create safe and easy to use Web 2 experience on top of a self-custodian blockchain wallet. That is our goal. And one of our evolving products is called the MOA, our multi-owner account. Very similar to things you can see in other networks like Gnosis Safe on the different EVM settings, networks. But we think that account abstraction on Starknet allows us to create a better and safer and more straightforward product. So our track on this hackathon really focuses on the MOA contract, and I'm going to share my screen and go over a few slides we've compiled on this project. And of course, after that, I'll be available on Discord and Telegram where we can interact. There's actually a lot going on, a lot of code, and it's very intricate and delicate, and our team will be available for any questions or consultations or anything you might need in the future. So let me just share my screen. Okay. I'll be back in a second. All right. Maybe I'll be able to do it now. Okay, desktop. Oh, okay. So I'm sharing the notes. So hope everything can be seen properly. So we are Braavos, and we're gonna chat a little bit about our multi-owner account. So a little bit of intro on the motivation and what makes multi-owner account on Starknet based on account abstraction more superior to previous solutions like Gnosis Safe. So a multi-owner account is pretty self-explanatory. You have multiple owners, and you would need some kind of a subset of these owners to sign transactions so they will be executed. And it's a very fundamental tool for blockchain developers and teams. you have a lot of delicate scenarios like upgrading your account. Let's say you have a Dex and you would like to upgrade to a new version. It's the correct way to do it is have multiple owners and have them sign. So a lot of organizations might need it. Maybe you're managing a lot of funds and you don't want to have a single point of failure, whether it's a security concern or maybe one of the developers might go rogue. So having some kind of MOA tool to control your workflow is extremely important. And the real strength here is that on Starknet, and specifically our MOA design, the MOA contract is not like a third party smart contract on the net, on the blockchain where different wallets are interacting with. The MOA is actually a wallet. It has a balance, a gas balance, and you don't need to send transactions from different accounts into it. And it seamlessly integrates with other dApps. So it's not like you have to send this big call data and save that and then have everyone sign that. It just integrates with dApps directly as if it's a regular account. And we also use, we can also aggregate the different security measures we have in different members of the account. So if, let's say you have several Braavos wallets who are the owners of this account, then you can utilize their hardware signer or their multi-sig signer, or you can, the idea is that it would be generic and you can use any wallet. So if you have another extra wallet that can do, that has other security measures you want, you can do that. And the idea is that the hope is that an MOA can be an owner of another MOA. You can go crazy with that. Those you can do many things, and I think there's a lot of room for innovation in this space. So that's a basic introduction to the concept of MOA. Let's talk a little bit about the different workflows we have with MOA. So the first thing you want to do with that is to set up an MOA account. So a group of users, let's say a group of users, a company, a bunch of developers around the world want to set up an MOA to manage their workflows. They would need to deploy this MOA account. In Starknet, the developers compile their contracts, they declare them, and then anyone can take the class hash, which is the output of the declare step, and deploy that. So a deployer of an MOA account would send a deployment transaction, and this transaction would have a unique list of the addresses that will, in fact, be the owners of this account. And it will also attach their public keys. We'll see that in a second. And the second crucial parameter here is the threshold. So let's say we've generated a list of 20 unique owner addresses. but we want this account. We think that 3 signatures is enough. So we will put a threshold of 3. So these are the 2 main parameters of the setting stage of the MOA account. The second workflow is, of course, sending transactions. Just a second before we move on to that, other than setting up all these parameters when starting, you can also, of course, manage the owners. You can add owners, you can remove them. If you got if someone lost their phone and they can't use the hardware signer anymore, they lost that account or something like that, you can remove them from the list. And you can also manipulate the threshold. You can add it or add to the value or remove it. So that's setting up and managing it. And of course, the important part here is how do we send the transactions? So the first step of sending a transaction is proposing a transaction. It can be some kind of multi-call of things you'd like to do. So the first person who proposes this transaction signs on it, and there's a pending transaction is generated in the account. And now it's pending and waiting for more signatures. And the next step is the other owners who would like to sign the transactions, they sign the pending transaction, they add their signatures, and eventually when we reach the threshold, the transaction executes. So the first step is there's someone who initiates the transaction. He proposes it, and it is saved and it is sent to the blockchain, and it's not executed, of course, at this point. And then, in a kind of like a rolling effect, the different owners sign the transaction. And let's say our threshold is 10, then once we reach 10 signatures, we can move on and execute the transaction. So in fact, the last signer executes the transaction. And notice that it's not like the last signer is the one who pays for everything, because this is not like Gnosis or something like that. The MOA is an account in it of itself, and it's the one that actually performs the execution. Okay, so how does signing work? So it gets a little intricate and complicated at this part. So we have 2 steps to our signing mechanism. The first step is just your typical Stark curve signing. If you remember when we were chatting about setting up this account, the MOA, the owner, the deployer of the MOA, they send a list of unique owner addresses, and they also send their public keys. So it's like a list of tuples of addresses and public keys. And then at the signature stage, when a user sends a transaction, the signature starts with the standard Stark signature. And it's very easy to verify this because we have the address and the public key, and therefore we can verify this address. We're going to see an example of this in a moment. So it will be clearer. And we also, every wallet has its own custom validation. So for example, a Braavos account can have a hardware signer. And it might be an MOA that, I don't know, has some kind of special signature. And whatever third-party option is out there, maybe another curve. So how do we do that? Well, we know the account address. We know the address of the owner, and because we know that, we can call the isValid signature method, which is a part of the account interface. And so we can query this endpoint and utilize more complicated validation schemas like hardware sign-up. So if I was one of the owners of an account and I was on my phone and I got a pop-up that says I need to sign our team is trying to upgrade the contract, and I get a pop-up saying I should sign it, then I would click yes. I would put my fingertip there and sign it with fingertip, and that message would be sent to the validate and execute stages of the MOA account, and it would validate the public key, and it would validate the signature using the public key, and it would also do a contract call back into my hardware signer account. It would call isValid signature with all the hardware signer signature, and my account would return true or false based on the validity of the signature. So let's look a little bit deeper into the details here. There are, and might be a little clearer when we see how a signature structure looks like. So the first flow we talked about was the deployment of the MOA contract. So we can see that in the constructor params. So when deploying, you need to supply two parameters, and that would be an array of contract address and felt tuples. So the felt is the public key of this address. So if we have 10 owners, then this would be an array with length 10 with the 10 addresses and the relevant public keys. And the second parameter is the threshold parameter. So let's say we had 10 owners, but we would we think that 5 signers is just about enough. Then we would put 5 in this parameter. So that's the first flow. The second flow would be to actually suggest a transaction to our team. So if one of the owners would like to suggest a transaction, they would send a multi-call that has the following structure. It always it always starts with a special call to a function called assert max fee. This is required by the contract, because otherwise you open up to different security concerns. So we ask the first user who generates this call to set some kind of limit to the max fee of the eventual transaction, just so to block different kind of malicious activities by malicious owners. And after that call, that would be the first item in the array, and the rest of the calls in the array, I just whatever function calls on Starknet you'd like to perform. So that would be the way to suggest a transaction. And the third flow is indeed signing a transaction for one of the owners. So if a user, one of the owners would like to sign a pending transaction, they would call the function sign pending multi-sig transaction, where they would attach the nonce of this pending transaction and the calls that are being executed. And the signature structure is, well, there's an example here of how a signature structure might look like for one of these transactions. So let's say I'm one of the owners and I'd like to sign a pending transaction. Then the first felt I would send in the signature field would be my address. And the second field would be the public key. And in this, so the first thing the contract, the MOA contract is going to do, they will take the R and S, which is the signature, the curve, the star curve signature, and they would verify that. They would also take the address and the public key and make sure they are indeed stored in our contract, and that this is an actual owner and not some random account. They would take the RNS, which is the star curve signature, and verify it. And after that, after the address, public key, R, and the S fields, we have space for a custom signature. So we got the signature length, and then some signature length of felt items. And this is the space for the special signature. So if the owner is, for example, a hardware signer, then this would be all the signatures that were generated by a hardware signer. And this is exactly the part that will be eventually sent to the is valid signature call, which we presented here. So this is the basic structure. Now notice that this is actually, it's you don't have to have only one signer. So if you could get signatures for multiple owners, you can send them in one go, but it doesn't have to be this way. So that is a little more in-depth look into the MOA account and the way it works and the different endpoints that it has. There's a lot of complexity here, and we can, of course, we will be able to share, first of all, the code for the MOA account, but we will also share some code snippets, a client code snippet that can interact with this contract, and send the signatures properly, and a few end-to-end tests that illustrate how this works. So you don't have to go in blank without any information and try to guess how it works. So let's talk a little bit about the bounty. that we're suggesting here. So we have two bounties that we are interested, but of course, if you have an idea for a third bounty, that would be also would love to hear that. But the first bounty we thought about is having an integration with Starkly. So Starkly is a CLI tool to interact with the Starknet blockchain. It supports different accounts. And what we were hoping for is supporting the MOA account as well. So extend Starkly with different workflows. For example, initializing an MOA account. So Starkly would, deploy an account with all the parameters and list of owners. You'd be able to add owners, remove owners. You'd be able to send transactions, and you'll be able to sign transactions. So like one user with Starkly would write a CLI command that would suggest a transaction, and another user would just be able to do, Starkly MOA sign, and that's about it. And that would add a signature to that pending transaction. So that's what we're hoping for. That's bounty number one. Bounty number two is very similar, but does require a bit more research and a little more understanding of Cairo, and actually going into the contract and updating it. So at the moment, the MOA account is not completely does not completely support DApp integration. So if you recall, it has a very specific signature structure, which is not supported by all wallets, and for example, Ardent or others, or the Open Zeppelin account. So we're trying to think of a way to update the MOA account to be completely generic and work with different kind of wallets. And the specific idea we were thinking about is using SNP 12, which is the standard for signing messages on Starknet. And different wallets, like the Braavos wallet, Argent wallet, they all support this SNP, so they are able to sign different messages. And we do think that this would be an interesting extension to the MOA contract. So just handle signatures of different message blobs and use that as the authentication. So this has a lot of research and going into the works of the MOA contract. So really cool project. That is about it. Thank you for your time. Like I said before, these are just two of our ideas, an integration with Starkly, and the integration, the DApp integration. We're looking forward to hear the participants, and maybe if you have other ideas, that would also be great. And we are available on Discord, Telegram, and other platforms, and would be happy to actually take the teams that are working with us really deep into the code, understand how it works, um, and look into our end-to-end framework that will show you how to use the account. So if anyone has any questions, now would be a great time. I think only seeing the Zoom participants. But if anyone has any questions, you can reach out to us in the Discord room. Me and the other team members will be listening there to any questions. Yeah. So, Matteo, do you have a question? No. Okay. So, thank you all for joining in and listening, and we'll be happy to hear back from you and really ramp you up into our ecosystem and our code, and see the products you'll generate. So thank you all.